So we'll do a question here. Find state transition matrix of a system having A is equal to 0, 1, 0, minus 2. So we know the matrix A, we have to find out the state transition matrix. So how will we find out? The easier method is to use the Laplace transform. So we know that phi of t is equal to inverse Laplace of Si minus A inverse. Okay. So what will be Si minus A? First we will calculate. This will be equal to S minus 1, 0 and S plus 2. Now what will be the inverse of a matrix? Si minus A inverse will be equal to adjoint of that matrix divided by the determinant. Okay. So determinant anyways it is straight and simple, 1 by S into S plus 2 minus 0. What will be the adjoint matrix? So this is going to be S plus 2, 1, 0 and S. So this is going to be 1 by S into S plus 2, 0 and 1 by S plus 2. Now we want to take the Laplace, inverse Laplace of this matrix. So what is that? Will give you the state transition matrix. L inverse of 1 by S into S plus 2, 0 and 1 by S plus 2. Okay. So this you are going to get 1 by S is anyways 1. 1 by S into S plus 2 you can write as S plus 2 minus S by 2S into S plus 2. Okay. So you can verify this. This is an easy method of dividing into partial fractions. Okay. So what are you going to get here? This is equal to 1 by 2, 1 by S minus 1 by S plus 2. Now what is the inverse Laplace transform of this? So it's going to be 1 by 2 into 1 minus e to the power minus 2t. Zeros anyway zeros. Here you are going to get e to the power minus 2t. Okay. So this is the final answer. The next question, for the system x dot is equal to some a x plus b u. A and b are given. Y is equal to c into x. With u as unit impulse and with 0 initial state, the output y becomes. So here what are all the additional information that is given? U is a unit impulse function. Okay. And the initial conditions are 0. Now what is y? This is equal to 4, 0 into x. So first we need to find out x. Okay. What will be the solution of x? This is going to be equal to L inverse of Si minus A inverse B into U of S. Okay. Here there is no initial condition, so the homogeneous solution will be equal to 0. Remember, this inverse Laplace is for the entire function. So first we will find this out. Si minus A. What is Si minus A? Here A is given as 2, 0 and 0, 4. So you are going to get S minus 2, 0, 0, S minus 4. Okay. Now what will be Si minus A inverse? This will be equal to the adjoint by determinant. So determinant is 1 by S minus 2 into S minus 4, and this is going to be S minus 4, 0, 0 and S minus 2. So you are going to get here 1 by S minus 2, 0, 0, 1 by S minus 4. Next we will write Si minus A inverse B into U of S, right? So we can take 1 by S minus 2, 0, 0 and 1 by S minus 4. B is given as what? Here in the question B is 1, 1. So you can write here 1, 1. And what is U of S? If U of t is equal to impulse, unit impulse function, then U of S is simply equal to 1. So here you will write into 1. Okay. So what will this be? 1 by S minus 2, 1 by S minus 4. Okay. Now the inverse of this will give you the state vector. Okay. So now L inverse of Si minus A inverse B into U of S is equal to e to the power 2t e to the power 4t. This is equal to the required solution x of t. Okay. So now we can write, therefore y is what? It was equal to 4 into 40 into x of t. So you are going to get 4 0 e to the power 2t e to the power 4t. So the output is going to be 4 e to the power 2t. Okay. The next question we have, a second order system starts with an initial condition of 2, 3 without any external input. The state transition matrix for the system is given by e to the power minus 2t, 0, 0, e to the power minus t. The state of the system at the end of 1 second is. So what is it that they are asking? They are asking the state only. That means the state vector at t is equal to 1. So that means x of t is equal to 1. So what will this be? Since it is a second order system, you will have two variables, two state variables. So x1 of t is equal to 1, x2 of t is equal to 1. This is what you have to find out. Now another information that is given is there is only initial condition, there is no external input. So then what will be the solution? That is only due to the initial condition, no external input, right? So x of t is equal to phi of t into x of 0, where this is the state transition matrix which is already given. X of 0 is the initial conditions which is also given. Okay. So you can get x of t directly. What will this be? E to the power minus 2t, 0, here also 0, e to the power minus t, and x of 0 is 2 and 3. So what will you get here? 2 e to the power minus 2t, 3 e to the power minus t. Okay. So now you just need to substitute t is equal to 1 here. Okay. So 2 e to the power minus 2 into 1. You are going to get 0.271. Okay. Similarly, here if you substitute t is equal to 1, then you are going to get 1.104. Okay. So this is the required solution.